And that's most of the content we've been through there. Quite a short section, really. The best thing you can do with this is just have a go at a few questions. There's not much content, but it definitely is worth having a practice to make sure you can master the exam questions. So I'll have a little look at one now. So there's a furniture shop. 40% of its customers buy a sofa. If they buy a sofa, there's a 70% chance they buy a coffee table. If not, then there's only a 25% chance they buy a coffee table. What we want to do is draw a tree diagram to represent this information, and then we're going to find the probability that a customer actually buys a coffee table. So always worth having a go at these. Pause the video now, have a quick go. Especially the second one you might find a bit tricky, but certainly have a go at drawing the tree diagram and make sure you can turn a question into a tree diagram. It's really important to be able to do that. Have a go now. Okay, hopefully you've had a chance to have a quick go at that question, or at least have a think about it. So we'll go through it now. So the first branch is going to be whether or not the customer buys a sofa. So we'll call this S for sofa, and we'll say not sofa here. Okay. The probabilities for that were 40%. I'm going to write 0.4. Buy a sofa, 0.6, don't buy a sofa. And then the second branch says if they buy a sofa, which is up here, there's a 70% chance they buy a coffee table. So I'll put C for coffee table, and then not C for don't buy a coffee table. So there was a 70% chance here, which means there must be a 30% chance they didn't buy a coffee table. Okay, each set of branches has to sum to 1, okay, because everyone on this branch has to be accounted for. So 70% do buy a coffee table, 30% must not buy a coffee table. Now down here, the probabilities were a bit different. So if they don't buy a sofa, only 25% of people buy a coffee table. So the 25% goes up there. Because 25% did, that means 75% mustn't have bought a coffee table. Okay, and that is what our tree diagram looks like. Not too bad, that one, but you can see these are not independent events, are they? They're not independent because whether or not they buy a coffee table depends on if they bought a sofa, which kind of makes sense, doesn't it? If you're buying a sofa, maybe you're redoing your whole living room, so you're buying a coffee table as well. You're more likely to buy one than if you didn't buy a sofa. So it kind of makes a little bit of sense. Now, this second part of the question, find the probability the random customer buys a coffee table. Well, which branches give us a coffee table? Well, it's this one here, we end up buying a coffee table. And this one here, we also end up buying a coffee table. So these are the two possible paths which end up with a coffee table. So to work out the probability of this branch, we're going to say, what's the probability that they bought a sofa and a coffee table? We're going to multiply those together, which is 0.28. And for this one, we're going to say, well, what's the probability they didn't buy a sofa but did buy a coffee table? That's 0.6 times 0.25, which is 0.15. Now, those are the two possibilities. So it's this or this. So we're going to add them together. So the probability that they buy a coffee table is 0.28 plus 0.15 for those two possible branches that end up buying a coffee table. Add those together, we get 0.43, or 43% of customers buy a coffee table. Okay, so hopefully that made sense to you. It's all about deciding whether to multiply or whether to add. Whenever we're at the end of a branch and we're thinking we had to do this and this to get there, that's multiplying. But if we need to add two possibilities together, which in this case we had two different possibilities which ended up with a coffee table, then you need to add those results together. And that's all I've got for that one. Quite a short video, which is nice. And we're done with probability now. There's only Venn diagrams and tree diagrams in that topic. So next time we'll be looking at something totally different and totally new, which is distributions and looking at the binomial distribution. You've done a little bit about that in AS, the pure math section, but we're going to take a bit of a statistics slant on it this time. So thank you very much for watching. Loads more about tree diagrams on the Solve4x website. Just navigate to that lesson and there's all the quiz questions and all of that stuff on the website to have a look at if you need a few more practice questions. But thanks very much for watching this one, and I'll see you next time.